Hello guys, so we are going to continue the discussion with respect to linear algebra. Now in this videos and in this series of videos that are coming up in this particular module is super important because now we are going to discuss about functions and linear transformations. Now whenever we talk about functions, these are not like coding functions and all. We'll just try to understand in terms of linear algebra what exactly are these functions. And as we go ahead, you'll also be able to understand about something called as transformation. Now these topics are super important for understanding some of the amazing algorithms in machine learning like dimensionality reduction, principal component analysis, and many more, right? So it is important that you try to understand this and try to relate it how it is really important for the data science field. Initially what I'll do is that I will try to explain you about what exactly is functions and how things are written in terms of functions in this particular case, basically in linear algebra. Then in the upcoming videos, I'm going to show you multiple examples wherein I will try to show you about vector transformation, matrix transformation, and many more. Okay. So first of all, let's go ahead and understand about the definition of function. Okay. A function is a mathematical relationship, okay, that uniquely associates elements of one set, which is called the domain, with elements of another set, which is called as the codomain. In simple term, a function maps input to outputs in a specific way. Okay. So let me just go ahead and write this notation. And with the help of this notation, we will be able to understand the further topics. Okay. So let's say I have a function f, and usually a function can be denoted by small f, it can be g, in most of the test books it is written in that way. So a function f mapping elements from set x, okay, we will consider this as domain, to set y, we will consider this as codomain. Okay. And this is denoted by, the notation is written something like this. F is the function and it will be written as x tends to y. Okay. Now this basically means a function f is mapping all the elements of x, which is also called as the domain, okay, to the y, which is also called as the codomain. Okay. So if I write like this, if something is denoted as like this, so here we can basically write if x is an element, of x, capital X, this is small x, it can be an element of this particular set. Okay. Then f of x is the corresponding element in y. Okay. Corresponding element in y. Everything will make sense once I probably give you some examples. Okay. So let's take this as an example. So here I have an example, and let's consider that I'm having a function which is called as f of x is equal to 2x plus 3. Now what does this basically indicate, right? What does this f of x basically indicate? Here we can write it as it maps each real number x to a real number, okay, 2x plus 3. Yeah. So what happens is that whenever we are using this particular function, okay, if I say, hey, what should be the value? Let's consider that I have some x value as 5. Okay. Now this x is basically getting mapped with a function to y, right? So when this x value is placed in this function, right? So right now this function is nothing but 2. Sorry, this x value is nothing but 2. So once I place 2 over here, this is basically going to happen like this is what we are going to get, 2 into 2 multiplied by 3, which is nothing but 7. Now this indicates that this function f of x is mapping to which belongs to a real number. right? It belongs to a real number to another real number, which is 7. This also belongs to a real number, right? This is what exactly it actually means, okay? So I have some x value over here. Let's say this is some x value with respect to set. This is denoted by x. We are converting this into y set, or I can also say we are mapping from x to y by using a function f of x. That's it, right? Now inside this, I may have some different values. This may be 1 point. Let's say this is 2. This is basically getting converted to 7 after we apply this. There may be another value over here. This may get mapped to some other value over here, right? Similarly, I may have another value over here. This may get mapped to the same value. It may be the same value also, right? Obviously, in this equation, it is not possible because x value, if it is different, we will be getting a different mapping value. So here, this is what a specific function is denoted at. In some of the textbooks, it is also written as g of x, okay? But this is what mapping is specifically about, and this is how is the notation basically given as f colon x tends to y. That basically means I'm able to map from x to y. I'm able to create this relationship with the help of f, okay? But what exactly this is, okay? And this is really important for you all to understand. And this is where your application part will come into picture. Let's say I have a vector, okay? In this vector, I will just go ahead and write it down. And let's denote this specific vector. I have a vector, and this vector can have any values. Let's say I'm having x, y, z. Okay, so let's consider this is a vector. Now you know that this vector belongs to a real number, but this is a kind of 3 dimension, right? Let's say, so I'll just go ahead and write it belongs to a real number of 3 dimension. So if I consider this vector, let's say if I want to apply a function f, okay, and what will be the specific function that I really want to apply? I will just take as an example. Let's say this f of x function is nothing but x plus y, and along with this x plus y, I can go ahead and write this in this way. Okay, let's say that my f of x is nothing but it will be giving me another vector, which is nothing but it is a combination of x plus y, and this will be nothing but 6z. Okay. Now what happens if I apply this function to this particular values of this vector, right? It is going to map to a different value. That basically means once I go ahead and apply this function, what I'm actually going to get over here, this is my function. So my function is nothing but x plus y. So x plus y I will be getting over here, and this is nothing but 6z. So in short, and this belongs to a real number which is of 2 dimension, because now this vector is of 2 dimension. I have 2 elements, right? And what is basically happening over here? We are mapping this vector to this vector by using our f of x, right? This is just one example, and this example, what exactly it is basically doing? You had a 3-dimension vector, and it is basically getting converted to a 2-dimension vector. Please observe on this, right? Please observe over here. Initially, I had a 3-dimension vector, and now I'm able to convert that just by applying this specific function. Just by applying this specific function, we are able to map from a 3-dimension to a 2-dimension with respect to the output, right? So this is what exactly function is all about, If we go ahead with the definition, now see this definition. A function is a mathematical relationship that uniquely associates elements of one set called the domain, and this is probably called the domain, right, with elements of another set which is called as a domain. In simpler terms, a function maps input to outputs in a specific way. So if I give some kind of inputs, and if I apply a function on top of it, it will map to a different output over here, which we are able to get, right? It can be in terms of vectors, it can be in terms of matrices, it can be in terms of real numbers, it can be in terms of scalar value, anything it can be. But I hope you got an idea with respect to functions. Now you will be understanding why these functions are important, specifically in data science. There is one amazing example, which is called as dimensionality reduction. A very good algorithms we specifically learn in machine learning with respect to dimensionality reduction. there also we specifically apply this kind of functions, which is also called as transformation. Okay, which is called as transformation. So in our next video, we are going to go ahead and see what exactly is transformation, how do we perform vector transformation, what is linear transformation, everything we'll go ahead and actually discuss about it. Okay, so I hope you're able to understand. But just to give you an idea, if I want to probably showcase this notation of this real number where we have converted from 3 dimension to 2 dimension, I can also write like this. So I can also write like this. So f is a function which is mapping from a 3-dimension real number to a 2-dimension real number. Okay, here this is specifically called as the domain, and this is actually called as the codomain. Okay, till now just get to know about this specific point, and as we go ahead we will be talking about the next topic, which is called as vector transformation in much more detail. Okay, so let's go ahead and discuss about the next topic. Thank you.